Hello everyone, my name is Aditya Gupta and today I'm going to present a project on anomaly detection on unknown data using machine learning. The dataset that I have used is NSL and KDD dataset. So in this we're going to train an FNN model and we're going to perform two type of classification. One is binary classification, which is just going to tell whether a packet is an anomaly packet or a normal packet. And in the second, we're gonna further classify the attack type into four categories, whether it's attack type is a DDoS attack or a probe attack or U2R attack. So first, we're gonna go through the binary classification training model code. As you can see, it's pretty simple. My program starts from here. So we first define the number of epochs that we want to go through and the batch size. And these are the file paths. From this function, we're gonna get the data from those files. And this is the list of the features that we're gonna train our model on. Or this is the features that we're gonna select and train our model based on those features. Then we're gonna separate the training and the label, and we're gonna do it for training data and validation data and test data. Whether we're gonna save the features, we're gonna then perform data pre-processing. First step will be separating the encoding data and then encoding it and then encoding the label data. Then after encoding, we're gonna scale the values from 0 to 1. Then we're gonna convert it into NumPy array. So for training the model, I have used a random search class. This class is basically used for training model using hyperparameter tuning. What happens in the hyperparameter tuning is that it performs training of a model based on a different set of hyperparameters provided by us. For example, uh, there can be maximum trial and there can be execution per trial, and dynamically it's gonna choose different sets of hyperparameter values and gonna train a number of models with a different set of values. So after training the model, it's just gonna create a different array of different models. And once the training is finished of all the models, we can get extract the best model out of those trained models. Then we're gonna extract the best model and perform the prediction on that best selected model. And the test data set we're gonna pass for the prediction. Then after that, we're gonna calculate various uh, parameters like confusion matrix, accuracy score, and we're gonna just append those on the list data. Then we're gonna perform the classification report, and at last we're gonna save the model. So as you can see in the get model function, uh, like I said, we are performing hyperparameter tuning. So in this function, what the random search class will do, it will just select different values dynamically. Now, coming to the multi classification training model. As I said, it's gonna classify into six classes. Four is the attack type, one is the normal data packet, and the sixth is going to be the other type of packet, like which is not even categorized as a normal packet, but also not as the attack packet. So the similar approach has been adopted for this training model as well. First, we get the data, we get the feature list, segregate the data, then perform pre-processing, and then again, I have again used random search, which is a hyperparameter tuning approach for training a model. After training, we calculated various parameters to evaluate the model. And at last, we're gonna save the model. So coming to the questions. When I train the model based on subset A, which comprises of E1 and E2 training data plus the normal data, and evaluated that trained model uh, by the A3 and A4 data set. Then the result was like for that model was 0%. Now, this 0% indicated that the model that was trained on A2 and A1 and normal data set, and when evaluated on training data set that is A3 and A4, this model predicted all the values wrong. So this indicates that the packet A3 and A4 are kind of a similar in nature with the normal packets. So because of that similarity, the model wasn't able to differentiate A3 and A4 packets as their attack type. It was able to predict it either a normal packet or some other kind of attack data type. But mostly in the research shows that it was quite similar in nature with the normal packet. That's why the model wasn't able to differentiate between these two packets and a normal packet, and hence predicted made a wrong prediction. And that's why the accuracy for this model is zero. Now, coming to the second question, uh, I trained the data set and I trained the model on the whole data set. That is binary classification I did. So the accuracy for that model was 99.73828%. As you can see the confusion matrix also. Coming to the third question. Uh, Seeing the data set A1 and A2, they were quite different. They are quite similar in nature. Whereas if you see data packet A3 and A4 type, they are quite similar in nature. So A1 and A2 couples along, and A3 and A4 couples along. Whereas if you compare that data type A1 with respect to normal data type, there is no similarity or hardly any similarity between those packets. They are quite distinct. Whereas if you compare the data packet A3 and a normal packet, they are quite similar in nature. That's why in question one, we saw that while predicting that a packet of E3, the model wasn't able to predict it correctly and predicted a 3 packet as a normal packet. And that's why the accuracy for the first question is 0%. coming to the fourth question. So when I train the model based on subset B and second model based on subset C and evaluated the accuracy of the model using a test data set. So here was the result. I mean, accuracy for model trained on subset A, the accuracy was around 68% for all the data types. Whereas model trained on subset B, the accuracy was 74.19%. Whereas the accuracy of the model trained on subset C, its accuracy was 76.67%. Now, going to the last question. The answer is like a yes. For a subset B and subset C, uh, both the subset has one type of attack which is quite similar to normal data type, and there is another attack type which is quite distinct from the uh, normal data type. So as a result, the accuracy for both the models that was trained on subset B and subset C respectively, it's kind of quite similar in nature. As you can see in question 4, the accuracy for model that was trained on subset B and on subset C, the difference is not much. Like in subset B, the accuracy is just 74, and accuracy for model trained on subset C, it's 76 only. So difference is not much because both of the subsets contain one type of data which is quite similar to the normal data type and the other which is quite distinct from the normal data type. That's why the accuracy is kind of a quite similar in nature. And that's all. Thank you.